Hello and welcome to our first video on objects and classes. This video is meant to be sort of a supplementary video introducing these topics in more of a bite-sized format. Let's start by discussing all the stuff that is probably around you while you're watching this. Your phone, your backpack, maybe your coffee mug. Each one has properties like a size or a color, maybe a weight associated with it, and things you can do with it, right? Like opening it, carrying it, holding it. In programming, we call these things objects. So let's just take a thing and draw it out and go from there. So let's start with this idea of maybe like your cell phone. These days, phones look something like this with all the different apps on it. I'm super great at drawing, as we can see. There we go. And like I said, we've got a bunch of different sort of properties, let's say, associated with our cell phone. Here's our phone, and here are the properties associated with it. We've got maybe a number of apps. We have a capacity. Nowadays, that capacity is in gigabytes. We have maybe a list of the applications that we can use. We have a phone color. The properties can be external or internal, as we can see. And then in addition to those properties, we also, I better like underline properties. This is the actual phone object. We have some behaviors. Behaviors like, answer phone, make a phone call, end call, and take picture, among other behaviors that you may be able to do within your phone. So here we have our object, we have the properties associated with it, and we have some behaviors. So when we actually think about what an object is, we should write down some kind of a definition. An object is a bundle of two things. One is going to be the state, meaning data or fields, or properties, depending on the word that you're most comfortable using. And the other thing is going to be behavior. This is our methods, our call to action items. All right. So we have all of our examples up here. We have our object. I've already used that color. Object, which will be equal to the state or various states plus our behaviors. There we go. So we can probably do this breaking down any number of items that we can see around us. Imagine a television has properties like a min and max volume, a resolution, a brand, a dimensions. It has behaviors like turning it off and on. Think about even your kitchen table perhaps has properties such as number of legs, number of people that can sit around it, the shape of it, if it's circular or oval, if it can be expanded or not, so a Boolean can be expanded, has a surface area, it could have some kind of behavior that would maybe make the table expanded, which would increase the capacity. It could have a behavior like checking to see if it's dirty or not and then cleaning it. Pretty much everything around us could be broken up into these states and behaviors, and everything around us is an object. Now, how do we actually tie this idea of objects back to code? Well, let's just draw a line here. And in order to do that, we need to define one more word. We've defined object, and now we're going to define the word class. A class how are we going to do this? A class is a blueprint. Basically, this is the blueprint you build an object from. A class will define what is possible, and the object is the thing you use. Okay, so let's imagine for a second that we can think of the term class as a blueprint. Perhaps you think of it as like a blueprint for a house or a car, and I often end up using the example of like a Lego brick model as well, the machine which makes Lego bricks. So we could also think about it as perhaps something a bit more common that we start with is this idea of a car class. Now again, if we think of the word class almost as blueprint, basically we're able to define all of those states and behaviors from before. So if we think about the states that we might want to define in a blueprint for a car, we might think of the number of wheels, the engine type, if it's fuel or electric. I don't know. We're going to start to reach the bounds of what I know about vehicles in a minute. If it has a screen, if it has cruise a min and max, kilometers per hour, stuff like that. And then we also, of course, have to define the behaviors in this blueprint. What are things a car could do? It can start, it can accelerate, it can brake, and we can turn the car off, among other things, right? This is just sort of a starting list. And basically our understanding is a program or a workforce could take this blueprint and start spitting out cars. Car 1 that maybe I own, car 2 that my friend owns, and car 3 that you own. We all have the same vehicle, make and model. It has the same state, it has the same abilities, but we each have our own version of it, right? We don't share a vehicle. If you have a Honda CR-V, or your mom or your dad or your friend has a Honda CR-V, you match my vehicle. But we don't share a car, we each have our own copy of it. So this is the basic idea that we're working with when we're trying to translate the world around us into code. What does this actually look like in code? Well, we've been making classes all along. Anytime you've written class or public class, and then a class name right here, and then you've saved this file, saved as that class name.java, you have defined a Java class or a blueprint. If we want to work with the current example that we're dealing with, we're talking about a car and car.java. And we have now defined our class. That's it. That's us defining a blueprint. Now, when we talk about our class in Java, we talk about sort of the building blocks that we need to have. So I'm just going to highlight those in red. This right here, actually I'll do it in, I'll just underline it, I guess. That is our class access modifier, and we'll talk more about that later on, but for right now, just know that it could be there. It can be the word public, it could not be there, and it also might be the word private or protected, but really for now we're just going to focus on understanding that this is our class access modifier. Other things that our class has is, of course, the class keyword, right? So this is the class keyword. Just like we define an int with the word int, a double with the word double, or some kind of sentence or constant with the word string with a capital S string, we're going to define a class with the word class. That shouldn't be new to us at this point. We also know that we have a class name, and we're going to have our curly brackets. That's sort of the defining building blocks of our class. Then in addition to that, we're going to have all of our, whoops, that's not the right color or line thickness, our states and our behaviors. And again, this isn't actually all that new to us. We've done this before, right? So if we wanted to add some states based on what we wrote up here, we would have an int. Here, let me just erase this. Actually, I'll leave that and I'll just rewrite it all out down here. We'd have a public class car, and we would have an int num wheels, and maybe a boolean is, is car on. And these would be considered our states or our fields or our properties. There we go. And we could also have something like our behaviors, our methods, like void turn car on, where we would say is car on becomes true because we want the car to be on. And this is a behavior. And all of this, oops, wrong color, would be stored in a file called car.java, just as we would expect. All right, once we've defined our blueprint, just as we can see here, we need to be able to make objects with our blueprint. Now, while we haven't really done this before, because in 10.10 you would not have used multiple Java files, and in 10.12 you did Python, it's important for us to understand that we actually can write multiple Java files that interact with each other. So let's move these here out of the way for a minute, just for space saving. And let's make another file right over here called main.java. We have a public class main. And here's where we're actually going to put our main class. And as we know, when we want to define a main class, we need public static void lowercase m main capital S string array of arguments. Okay. So now we have our main class, we have our main method. How is it that we can now make the car objects so that each person or each object that we make is its own individual entity? So let's go ahead and do this right now. We would do this by saying, just like we would with a new string variable or a new int, capital, whoops, keeping on my eraser there, capital C car1, and now here's the important part. We need to actually say new car. Now this looks a little bit like what we do with our arrays. When you made a new int array, you had that new keyword. We still need that new keyword. So you'll notice here that we have car. I don't like that it highlighted it like that. That we have car right here. That we have capital C car right here. Both of those are literally the capital C car over here, although I now realize this doesn't really look like a capital C, so that could be confusing. We have that new keyword that we have to have, And then we also have our variable name right here, which I've just decided is going to be called car1 for right now. Now we've made a singular car, car1. And just like our example up here where I told you that we would have a car1, a car2, and a car3, we can do the same down here. We could make another one. Car2 equals new car. And you have now created two separate car objects. Now it's worth noting, let's just add something a little bit easier to follow here. I'm going to add a string for this car color. It'll be a little bit easier for us to work with a string color for a minute. I don't know what color vehicle you have, but if we pretend like car1 is my car and car2 is your car, I can tell you that my car has a color that is white. And perhaps your car is a color that is blue. And we can see that we have two separate vehicles. We have my car and your car. They may both be made with the same building blocks. They both have a color. They both have some number of wheels. They both can be turned on. But they're not the same vehicle. My car has a color of white, as I've now defined with car1.color equals white. And your car is blue. Car2.color equals blue. Now, it's really important we understand the difference here. This blueprint right here is our class. I'm just going to close up this here. So this is a class and this is a class, meaning everything inside of it is the blueprint for said class. Everything even inside this is the blueprint of a class. But a class is not an object. The class defines it. The object is the instance. Objects live in memory. Variables hold references. So this is our first introduction to the idea of memory in our computer and how things are actually being stored. So I used a few different words there, and I just want them all very clearly defined. We have variable, we have object, and we have class. Now we understand that a class is a blueprint. It's kind of like a machine that spits out objects. Now the way our code is actually stored under the Java hood is we're actually stored in two different places. We have code that's stored in a special area called the heap or heap memory. And we have code that's stored in a special area called the stack or stack memory. I like to think of the stack a bit like a notebook, about the size of a notebook, and I like to think of the heap a bit more like a magical cloud. Now, whenever we create variables, such as car1 and car2, we write them down in our handy dandy notebook. And I know that that's Blue's Clues, but here we are. And what they're actually doing is they're actually just storing an address in memory, just like a house address, that tells us where we can go to find the object data. So over here is memory address 1, 2, 3. There's a page of memory, the size of a car with the color white stored in it. Running out of room here. And another page of memory over here with the color blue. And this is important to understand because when we actually reference car1.color, what we're really saying is go to the memory address stored in car1. So we walk over here and find the color state and tell me what it says. Or when we do car2.color, same idea. We go to car2, we go to the car2 memory address, follow it along, find the color variable in there, and find that it says blue. So this is really important to understand how our memory is actually being stored. Some people might draw it like this. Instead of putting memory addresses, they might do this. and just draw an arrow referencing the box instead of the memory addresses. Both are okay. Both are ways to represent it. In reality, it is memory addresses, but some people do prefer to draw it with a arrow just to make it a little bit easier to find. Okay, so far we've covered the idea that objects, where is it? We'll go all the way back up. We've covered the idea that objects are basically a bundle of states and behaviors, while classes are this idea of a blueprint. While multiple objects can come from one class, each one can be made up of its own set of state variables. Each one has its own copy of state variables, each with its own defined qualities. In the next video, we'll look at classes a bit more deeply, where we will discuss these different fields, go into more depth around this, as well as discuss the behaviors, meaning the methods that we've covered. Look around your room and pick an object that's near you. Maybe it's your TV, maybe it's your couch, maybe it's your computer, and try and think of 2 fields that you could associate with that object and 2 methods. I'd also like you to maybe take a moment and think what might happen if I were to go in to my code and delete car.java. What would happen to this file over here? Would it still work? Can the objects car1 and car2 exist without car.java? What do we think? I'll give you a hint. They cannot. So take a moment to think about that, to consider it. Try drawing out these 2 classes in your code. Try writing them out. And meet me in the next video for a deeper dive into these fields and to start to discuss methods. Thanks so much, and I'll see you in the next video.